Now we're going to look at some basic questions. Make sure you notice the process really is pretty straightforward as far as creating the confidence interval itself, but the interpretation is what is important, and the ramifications of how these numbers work together is also extremely important because there's some things that can get wrong. We take a random sample using appropriate procedures again. So I mentioned this because I want to make sure that our results will be unbiased, or the procedure is unbiased. We intended to use a 90% confidence interval. Great. Once the data is collected, your boss says change the confidence level to 95%. How does changing from 90 to 95% affect the margin of error? All right. So let's look at the formula again for the margin of error. The margin of error is equal to Z star. And again, what I'm about to say is true of any statistic. We're just using this one. And here we go. That's your margin of error. Now, what corresponds in this formula to confidence level? And the answer is Z star. Z star connects to confidence level. And we'll notice that, again, for Z star, for 90%, we didn't go 90%, but if you did the process, you'll see that it's 1.645. That's a value for Z star. By the way, I just have this memorized. It's hard to forget after a while. 95% is 1.960. So you'll notice that, and this is 90%, corresponds to, this corresponds to 90% confidence level. Well, this one corresponds to, they're not equal, notice, just I'm putting a little arrow to say is connected to somehow, to 95% confidence level. And you'll notice that as the confidence level goes up, the Z star goes up, and notice this is staying the same. This is not changing. So the standard error is not changing. The only thing that's changing is Z star. So what does that mean? Margin of error increases. As confidence level increases. Now, some people, if I were to ask them, would say the exact opposite. Because don't mistake, confidence level with accuracy. And by accuracy, I mean how close our p-hat value is to the unknown parameter, which in this case, again, is also measured via the margin of error. So if you think about it, the reason our confidence level is going up is because we're making the margin of error bigger. And so therefore, we're more confident that we're going to capture it. So we have these two things. We don't know what this is, but what we do know that if this one is the confidence level for 90%, then the one for 95% is just going to be slightly bigger. Slightly bigger just means, well, there's a bigger chance of containing it. And that's why we're more confident, because we're making the margin of error bigger. That's all it is. Suppose we want to estimate the number of citizens in Oregon that would support a sales tax if income tax and property tax were lower. Which would yield a lower margin of error? A sample size of 1,000 or a sample size of 4,000. So again, the margin of error is sitting right over there. Notice that in this case, what we're messing with is not the confidence level. We're leaving that fixed. Instead, what we're suggesting is what we're about to change is n. So we're leaving this the same, but we're about to change this. Of course, changing this means that we're not going to have the same p-hat value exactly each time. But that's okay, because this is a general question. What happens to the margin of error as n increases? and which will yield a lower margin of error. Well, remember, as when you look at this formula, as n increases, standard error will go down. Standard error, the whole part here, not the margin of error, just this part, standard error, will decrease. And you know that because we've been doing that when dealing with sampling distributions. As n increases, the standard deviation will go down. So the 4,000, the sample of 4,000 will produce a smaller margin of error. And notice now this is about accuracy. Like, how close am I? So the confidence level has to do with how likely we are to capture this, but it's not about accuracy. As a matter of fact, the accuracy gets worse as you make that confidence level higher. Let me back that up. The confidence level has nothing to do with accuracy. As the confidence level goes up, all we're making is bigger and we're more confident, but making the accuracy worse. But n, as n goes up, keeping this fixed, it will do the exact opposite. It will make the margin of error smaller as n goes up. So the two are combating each other. Notice, do you remember this formula from algebra? 1 over x. I'm going to only draw the positive side. That's all I care about right now. But it looks something like this. And all this means is at the beginning, it's like in 0, 0. At the beginning, as we increase this value, which in this case is this n, we start to decrease fast the y value, which in this case is a standard error. And it has a particular property. Eventually it slows down. And that's what's happening here. As n goes up, there'll be an initial, the amount, the margin of error will decrease. It will be sharp, and then eventually it flattens out. Okay. True or false? The margin of error will account for samples that are biased. And the answer is false. I know it has the word error in it, but that has nothing to do with bias or an actual mistake. Error does not imply mistake. Okay? Let's just get this out of the way. That's not what this means. Error means an estimate of variation. After all, this formula here has the standard error. So the margin of error, of course, has to have the word error because it's using an approximation for the standard deviation, an estimate of variation. So that's all the error means. So the margin of error will take care of samples that are biased. The answer is no, as we shown earlier, that actually this gets worse. If you have a bias, it will get worse as the n goes up, or the margin of error decreases, for example. Nothing's really going to fix that at all. So that's not what this does. So this is absolutely false. True or false? In general, for a fixed sample size, as the confidence level increases, the margin of error decreases. Oh, I think this whole idea in general for a fixed sample size. So again, let's think about this. We're fixing this. Again, we're going to fix this, not moving as the confidence level increases. As this goes up, the margin of error decreases. Again, false. We just showed that. It's the exact opposite. As this goes up, the margin of error will go up. Okay. What is the purpose of creating a confidence interval? In general terms, the simple one, to estimate a parameter. Using a range of values. But possible. for the parameter. So again, what this means is that we know that the number we're about to produce using statistics is wrong. So using that as a center, we'll use a potential set of other values that could be the parameter. And why is that better? Because we know, again, this is not correct. What we're trying to now estimate is how far are we from here? You know, how bad can this get? How bad? If I just leave it as a single value, I'm guessing as to, well, how far am I away? The margin of error gives you at least an idea of, okay, it could be as bad as this or as bad as that, with a certain level of confidence of actually making sure that our parameter is actually in that interval somewhere.